So in a previous video, I did a review on an affordable DIY guitar amplifier kit from KLD. This particular one I got is based on a Marshall JCM 800, and overall the kit is really good, and it sounds great. But unfortunately, it doesn't come with any kind of case or cabinet, and as far as I can tell, there aren't any retailers that sell one, which means you need to build it yourself. Well, it's been nearly 2 years since I did the review, and I finally got around to building the cabinet, as you can see here. So in this video, I'll be going over the process of how I built it. Overall, I'm really happy with how it turned out. It's made out of high quality Baltic birch plywood, and the vents were 3D printed in an Art Deco pattern that I found on Thingiverse, but I'll get into more details on the vents later in the video. Let's begin by going over how I made the wooden cabinet. Now I first want to mention that I'm not an expert carpenter, and the way I built this cabinet is simple compared to how professional amp cabinets are built. Those use finger joints which offer superior strength, but this adds a lot of complexity, and for a build like this, I don't think finger joints are really necessary, and using screws will still provide plenty of strength. So if you're looking for a simple yet effective way to build a cabinet, then this video should be very helpful. Now, like I just mentioned, I used Baltic birch plywood, which is probably the best type of wood you can use for an amp cabinet because it's extremely durable and also lightweight. I opted to go for 1/2 inch thickness, which seems to be the sweet spot in my opinion. Although larger amp cabinets are usually made with thicker 3/4 inch pieces, which is stronger, but of course it'll also be heavier. So it's up to you whether you want to go with 1/2 inch or 3/4 inch. I got a good deal on a big 4x8 foot sheet at a local lumber store, which was sold at a discount because a small part of it had some minor cosmetic damage. But this is nothing some light sanding can't fix. I ended up paying around $30 for what you see here, which means I have plenty left over for future projects. Like I said, I'm by no means an expert carpenter, but I do have some experience building things with wood, such as my custom-built pedal board, which I've previously made a video about. I used a jigsaw to cut the wood for the pedal board and all the other wood projects I've done in the past, but it's difficult to make long and straight cuts with a jigsaw, so I decided to purchase a circular saw for this project. As you can see, it went pretty smooth once I got the hang of it, and although some of the cuts weren't perfectly straight, they ended up being good enough, especially after sanding them down. As always when using power tools, be extremely careful and make sure you take the appropriate precautions, such as wearing safety goggles. Before doing any cutting though, obviously you'll want to take measurements and draw an outline on the wood with a pencil. I suggest adding at least 3 or 4 millimeters to your measurements just to give you a bit of headroom in case your cuts are a bit too small. After cutting all the pieces, I orientated them around the enclosure to make sure everything will line up correctly. Now, the enclosure will be attached to the cabinet using screws that go into the holes that are located on the bottom of the enclosure. And you'll probably want to get rubber feet like these, which come with the appropriate screws. So the next thing I did was remove all the wooden pieces except for the bottom one, and then use a pencil to mark where these holes are. Then I drilled the holes in the wood and attached the enclosure with the rubber feet. So far so good. Now the next part are where things got a little tricky, which is gluing all the pieces of wood together while making sure everything fits nice and snugly, but also making sure it doesn't end up being too small to fit the enclosure. I was debating whether it would be a good idea to leave the enclosure screwed in or not for this. I wanted to be absolutely sure that it wouldn't be too small, so I decided to leave the enclosure attached. Now there's probably several different ways you can go about this, and there might be better methods, but I ended up cutting a cardboard box so that I could use it to prop up the side pieces of wood while the glue dried. But of course, when gluing wood together, you also need to apply some pressure, so you'll want to use some clamps as well. But this is also what makes this step kinda difficult, because when you apply pressure, then the side pieces of wood will likely want to fall over, which is why I used the cardboard box to help keep it propped up, and it ended up working pretty nicely. As far as the type of glue goes, any type of wood glue will work perfectly fine, such as this Gorilla Glue, which is what I used. After gluing both side panels and waiting a day or two for it to dry, the next step was to drill holes for the long wood screws, which will help secure all the pieces together. You'll want to use wood screws that are around 2 inches long. Generally speaking, the longer the better, and of course make sure they're skinny enough to fit into the side panels. After that's done, you'll want to repeat the process for the top panel. Glue it together, add some weight on top, give it a day or two to dry, then secure it with screws. So far so good. The box is assembled and it feels extremely sturdy. Also, if you plan to add a handle, then now's a good time to drill the holes for it. Now the next step would normally be to add Tolex covering if you want a professional looking cabinet. But this is a pretty involved process, so I decided to take the easy way out and simply stain the wood instead. I used a black colored stain since that's what I had laying around. If you haven't done wood staining before, then I suggest doing some trial runs on some scraps first before you do it on your actual project. Generally speaking, you'll want to heavily soak the rag so that it's completely saturated and put on heavy coats. Push down firmly and do wide strides with your arm so that you cover a large area with each stroke. You'll likely need to do several coats until the wood color fades away and is replaced by the stain color. I also stained the strips around the interior to give it a cleaner look. After staining it, you'll want to add some sort of clear coat to protect the finish. There's lots of different options for this, but I ended up using Minwax polyurethane spray with a warm gloss texture, which gives an overall better look in my opinion compared to a regular gloss which can look kinda plasticky and cheap. So now it's getting pretty close to finished. But before we install the amp, I recommend purchasing some copper tape for shielding. Most amp manufacturers include a metal plate on the bottom which creates a Faraday cage with a metal enclosure. This is important to keep the circuit shielded from outside interference, which may or may not be a problem in your area. If you live out in the country, then noise might not be much of an issue. But if you live in the city like I do, where there's cell towers, power transformers, and a bunch of other devices everywhere, then noise becomes a bigger issue and you'll definitely want to add some shielding. To do this, layer the entire bottom section of the cabinet with copper tape, and you'll also want to cover the sides up to where the enclosure ends like you see here. Make sure you layer each strip so that they're slightly overlapping each other. Now we're finally ready to install the amp. Fortunately, everything worked out perfectly, and the enclosure fits nice and snug without gaps on the side. The only thing left to do now is to add a front and back panel, but ideally you'll probably want to put vents instead of a panel to make sure the tubes stay nice and cool. Traditionally, most amp heads have a panel on the front and a vent on the back, but depending on the exact model, this could lead to overheating in certain scenarios. It really depends on the individual model whether overheating will be a problem or not. For example, many Vox amplifiers are notorious for overheating because of poor ventilation, and in some cases there have been reports of these amps actually catching on fire. Many modern amp heads tend to lean towards extra ventilation, so I recommend doing the same. It's probably best to use a vent made out of metal, but it might be difficult to find something that will fit, which is why I decided to create some vents with a 3D printer. At first I was thinking about designing my own pattern, but this would have taken a lot of time, so I ended up going with this Art Deco style design I found on Thingiverse. I think the aesthetic looks really cool, and it's a lot more interesting than a simple gridded pattern. The creator included an app that allows you to customize the overall size and the dimensions of the blocks in the pattern, which is really nice. So you can play around with different dimensions until you find a pattern you like. I left the link in the video description in case you want to use it for yourself. But if you decide to go this route, then chances are you'll run into the same problem I did, which is that the model is too large to fit on the printer in one piece, unless you have a really big printer. Even my large Ender 5 Plus wasn't big enough to print it in one piece, so I ended up splitting the print into two smaller pieces. Now, normally I control my printers using Clipper running on a Linux desktop PC, but for this project, BigTreeTech sent me their brand new Pi 2 SBC that's specifically designed for printers. Raspberry Pis are a popular option for controlling printers, but it's not a perfect solution, especially if you installed a Pi inside your printer. That's why BigTreeTech designed their own SBC for 3D printers, and they just recently released the second version, which has several improvements over the original, including a faster quad-core CPU, 2 GB of RAM, 32 GB of eMMC storage, and a PCI Express slot for NVMe drives. But one of the key advantages it has over the normal Raspberry Pi is the ability to run directly off a 12-volt or 24-volt power supply, which makes it the ideal choice if you plan to install it inside your printer. It also offers all the other features you'd expect from a Pi clone, including multiple cameras and display ports, and much more. So if you're interested in learning more or purchasing one yourself, then be sure to use the affiliate link down in the video description, since this directly helps out the channel. Thanks for the support. The Pi 2 performed flawlessly in this project and the prints turned out great. I decided to use PETG filament since it has a higher melting point than PLA. For this application, PLA will probably still be okay, but since the vents will be sitting right next to the tubes, which can get pretty hot, I think it's better to go with a filament that has a higher melting point, since it's possible you might get some warping with PLA in certain scenarios. But it's hard to say, and like I said, PLA might still be okay. After printing all 4 panels, the next thing I did was print rectangular braces to make it easier to glue the vents together. The last step was to tape the vents onto the cabinet in order to drill holes through the vents and the wood so that I could use small screws to secure the vents. Also, I'm thinking about designing and printing a customized logo or emblem to glue onto the grill right in the center, since I feel it looks kinda plain and empty there, and it could use something to give a final touch. I'm not sure if I'll actually use my channel logo or not. I'm just putting it here as an example, but you get the idea. Overall, I'm extremely happy with how it turned out. If I were to do it again, I might have considered using a different color stain, such as a dark brown or something, since the handle I got is brown and the chassis is orange. So perhaps a shade of brown would have matched better, but either way I still think black looks good. And when it comes to build quality, it feels extremely solid, and I'm confident it will hold up well in the long run. But I'm curious to hear what you think. Drop a comment and let me know what you think of the build and if there's anything you would have done differently. I think the way I did it was the simplest and most efficient way without sacrificing build quality too much. But anyway, I'm gonna end the video with a short jam session using the amp. So if you enjoyed the video, be sure to give it a thumbs up and also subscribe to the channel if you haven't already. As always, thanks for watching and I'll see you next time.